traveling at the critical angle, so there's a 90-degree refraction, which means that ray is not leaving the water, but there is reflection as well. In fact, every single drawing I've made that showed a ray going from air to water or water to air, I did not draw the reflected ray, even though I should have. So yeah, I'm going to get reflection and, if possible, transmission. So look here. This is not a complete picture of what's going on. Not only does the ray refract so that you get, transmission at an angle that's smaller, that is, the refracted ray is closer to the normal, but you also get reflection. And the reflection follows the rule of reflection. Angle of incidence equals angle of reflection. Right here, same thing. Sure, Snell's law describes refraction, but there's also reflection. This ray is going to reflect off the water, and this angle will be theta 1 as well. I need to demonstrate this to you with my aquarium.
The rest of it online, so make sure you actually get the footage, because I didn't really get good footage. I want to see this.
I got to mix up the glow in the dark powder.
Actually, lemon.
It's like
I am now going to shine a laser from below the water level, so that the laser will enter the water and then hit the water-air boundary from below.
Yeah.
Let me show this now.
Yeah. I have to go somewhere at 11.
Can you see the reflection? Can you see that my light is hitting the water and reflecting back?
What is this? One way to look at the water.
If I go at a higher angle, I can get transmission. Do you see that light on the far wall? That's transmission. I'm getting reflection off of this glass that's hitting my head. But I want you to see that at that far wall I'm getting transmission. That's because the light, and I wish I should have had this closer. I want you to see that.
It's going all over the place.
Can you see I'm getting transmission? Can you see the laser here? Okay, so there we go. So I'm getting transmission and reflection. All right, are you guys able to see that? Okay, so that's it. There's a name. If I have the angle of incidence so large that the angle of refraction is 90 degrees or greater, so no light escapes, then I get this situation. And this is called total internal reflection. So, can you guys see that okay? This example of total internal reflection, where my laser hits the boundary of the water and the air and just bounces right back into the water. Total internal reflection. You guys okay with that?
Yeah.
Because I'm so into it that I'm not really keen on you guys. So I'd like to draw on the board what I was doing with the aquarium for the people at home who maybe can't. I don't know if the camcorder does like this. So that you can see the laser. If that's just clear water, you're not going to see the laser in the water. Oh, a glow in the dark powder works best. You're right, any powder would work. I could put chalk in there, but I just find the glow in the dark powder, it glows better, it gives off light better. Yeah. So here's what was happening. I just want to say again, here was air, here was water, and I shined light to the boundary, but because the angle of incidence was equal to or greater than the critical angle, no light escaped the water. All of the light just reflected right back. And the name for this is called total internal reflection. So looking at your calendar notes, I'd like you to read problem number 9. If the angle of incidence is greater than the critical angle, then you get total, yeah, please write that down. And so now, I'd like you to try problem number 2. Look at problem number 2. A light ray passes from glass into air. The glass has an index of refraction of 1.5. The air, of course, has an index of refraction of 1. And they want to know what the critical angle is. They want to know what that critical angle is. In order to use Snell's law, you need 3 of these 4 things. I know N1. If I call this N1 and I call that N2. I know N1, it's 1.5. I know N2, it's 1. I don't know theta 1, that's the critical angle that I want to find. Do I know theta 2? What is theta 2? Yeah, 90 degrees. I want to remind you, in finding the critical angle, the angle of refraction is 90 degrees. So please use Snell's law now and find me the critical angle of glass. Index of refraction is 1.5. Good luck.